We are going to finish up this unit with a really cool topic that's going to carry us through section 3.6 and 3.7. The I can statement here is I can solve systems using augmented matrices. So we'll write matrices here, augmented matrices, and row operations. Row operations. Okay, so I can solve systems using augmented matrices and row operations. That's going to be our focus for this section and the next one. So are rows in a matrix horizontal or vertical? Now again, not to insult anybody's intelligence, but if you forget which is horizontal and which is vertical, which is a row and which is a column, that's going to be big trouble. The rows are horizontal. They're horizontal, they're like this. Okay, remember the columns are straight up and down. What does it mean when you augment something? Well, if you augment something, you normally make it bigger. Okay, you add something, so I'm going to say add something to it. Okay, add something like this. And then I've got a little equation right here and a question. It says if 2x plus 4y equals 6, does negative 20x minus 40y equal negative 60? And the answer here is either yes, no, or maybe, and then we need an explanation for the answer. Well, on this one, you might remember that as long as we do the same thing to both sides, we get another true equation. So the answer on this is yes. And what was done here is they actually took this whole equation, everything on both sides, and they multiplied it by negative 10. So if we did negative 10 times every single one of these, we would end up with negative 20x minus 40y equals negative 60. So we get another true equation, okay? So we multiplied both sides by negative 10. And as long as you do the same thing to both sides on an equation, you're going to get another true equation. So we've already learned how to solve systems of equations. And 2 by 2 systems, remember, have 2 equations and 2 unknowns, so 2 variables. That's why we call them a 2 by 2 system. And when we solve a 2 by 2 system, what we're doing is we're finding the point where the lines cross or where they intersect. Now, a 2 by 2 system looked something like this. We always made them look like this. If we were going to graph them, we might put them in slope-intercept form or something. But remember, our favorite techniques were either substitution or elimination. If we could eliminate, that was awesome. And the graphs always looked something like this. We normally got one single point where they crossed. Sometimes they didn't cross at all, so there was no solution on that one. And then over here we've got, notice how this is kind of a purple color. Those lines are right on top of each other, so we get an infinite number of solutions. So one solution, no solution here, and infinitely many solutions here. Now remember these vocabulary words, consistent and inconsistent, dependent and independent. Consistent meant that it had an answer. So both of these systems right here, the first one and the third one, those are consistent because they have answers. Inconsistent means it does not have an answer, so that would be this middle one right here. And then dependent means the answers for one depend on the answers for the other. So this one would be consistent and dependent, whereas this one right here, they're independent of each other, so this one would be consistent and independent. So just a quick little review here. Now, what I'm going to do is I'm going to go through and I'm going to solve a 2 by 2 system. I'm going to solve this one right here, but I'm going to do it in kind of a weird way. But I do want you to stick with me because this is going to pay off in the end. It's going to kind of show you why we're going to do the problems the way we're going to do them today. And this is not it. I'm just doing a demonstration here. So take a look at this. What I'm going to do is I'm going to say, look, I like this one right here. I'm going to use it to eliminate that one. So I'm going to take this. There's a 1 right there, and I'm going to multiply it by negative 3. So when I multiply it by negative 3, here's what I end up with. I end up with negative 3x. I end up with plus, that would be plus 6y, and then this would be negative 6. Now, I like this equation right here, so I'm going to do something that's going to seem kind of silly. I'm going to write down 1x minus 2y equals 2. I'm going to write that equation down again. And then instead of writing down the one that I don't like, I'm going to write down what I get when I combine these together. So I get no x's, so I'm going to write down 0x. Those are eliminated like we want. And then I'm going to get 1y, so I'm going to put plus 1y here. And then over on this side, we end up with a 3, okay, because 9 minus 6 is 3. Now, that seems a little bit silly, but I'm going to do something that's going to seem even worse right now. I'm going to take this one and I'm going to say, look, I'm going to get rid of that right there. I realize I can already see what y is. I want to get rid of this one right here. So here's what I'm going to do. I'm going to take this one and I'm going to multiply it by 2. So if I multiply that by 2, I get no x's, and I get 2 y's, and I get, let's see, what would that be? That would be a 6, okay? Now, here's where it gets really silly. I'm going to rewrite that last one because I really like that one. That one tells me that what y is right there. And then I'm going to rewrite this first row by doing this first equation. 0x plus x is going to be 1x. And then 2y minus 2y is going to be 0 y's. And then over here, I end up with 2 plus 6, so I end up with 8 there. Now, that's kind of a crazy way to do that. But if you'll take a look here, this one says that if I have 1x and no y's, I end up with 8. So that means that that first equation really means x is equal to 8. And this second equation says if I have no x's and 1 y, I end up with 3. So I end up with y equals 3. So the answer on this one is 8, 3. Now, this is a crazy way to do this, but even when we're solving things using substitution or elimination, we tend to make mistakes. And what I've done here is I've just kept track of things in kind of an organized fashion, but I had to keep writing things over and over again, especially the x's and y's. Well, one thing that mathematicians are really good at is keeping stuff organized, and one of the best ways they organize things is using a matrix. So let's write down matrix right here. So that's one of the tools that mathematicians use to keep things organized. Now, whether we did it the kind of the silly way or we did it using substitution or elimination, we're always writing down x's and y's over and over and over again. So we're going to use matrices to show how we can do this in a little bit more organized fashion using something called an augmented matrix. So it's going to allow us to get rid of the x's and y's. So let's take a look and see how an augmented matrix might be able to help us. So here's what an augmented matrix is. It's a matrix formed by augmenting the x column and the y column with the answer column. Okay, we usually put a solid or dotted line between the y column and the answer column. So here's how it works. All we're going to do is we're not going to solve anything here. All we're going to do is just write down an augmented matrix. So there's a 1 here and a -2 and a 2 here. So we're going to write down, first row is going to be 1 and -2 and 2. Pay attention to spacing on this. This is going to be a 3, a -5, and a 9. That right there is the augmented matrix, but again, we normally put a line or a dotted line in between those, normally a solid one right here. This is an augmented matrix. So if all it said was write down an augmented matrix, that's all we need. So what this depends on is organization again. We've got to have the x's in the same place, the y's in the same place, the equal sign in the same place, and then the number answers on the other side. So as long as that's the case, we can just write down the augmented matrix, and then this is going to be the x column, this is going to be the y column, and then this is going to be the answer column. So let's write down an augmented matrix for this one right here. They're in the correct order, so this is going to be a 1, 2, and a 5. And this is going to be a 1, a 1, and a 3. Go ahead and put the box around that, put the line right there, and then you're all set to go. This is the augmented matrix. We've got the x column, a 1 and a 1, the y column, a 2 and a 1, and the answer column, a 5 and a 3. Now, since the matrix keeps the numbers organized, we can now solve the system using what we call row operations. So we're not thinking of these equations as equations anymore. We're just thinking of these as rows, and then we're going to play a bit of a game. Now, these row operations that we're talking about, they're used in a branch of higher mathematics called linear algebra, and I think I already mentioned that earlier, but maybe not. So you can actually get a degree in linear algebra if you wanted to. So all we need to do in this section is just get used to how to write down augmented matrices and how row operations work. So the row operations are as follows. There's 3 of them, okay? So when working with an augmented matrix, here are the 3 things that we can do. We can interchange any 2 rows, so we can switch row 1 with row 2 or vice versa, or row 3 if we've got 3 of them. We can replace a row with a non-zero multiple of that row. So this is called row swap. This one's called times a row. We're just going to come up with a little shorthand here. And then we can also replace a row by the sum of that row and a constant multiple of another row. So we're going to take a row, we're going to multiply it by something, and we're going to add it to something else. Now, if that sounds kind of familiar, that is exactly what we do when we eliminate. That's exactly what we did here. So if we were just doing elimination on this one, what we've done is, and I'm going to replace the word equation with row, we've taken this row, multiplied it by -3, written it down here, and then we replace this second row with what we get when we add those together. Okay, so what we're doing here is we're kind of systemizing this elimination method. So I'm going to flip this over to the other side. I want you to do the same. Again, we've got these three things that we can do, these three row operations. We can swap rows, we can multiply a row by something, and we can times a row, and we can add it to another row. Now, to make this easier, we want to keep track of what we're doing by using some shorthand. So the shorthand looks like this. So we're going to number the rows R1 and R2. So that's going to represent the first row and the second row. If we swap rows, we're going to do this. We're just going to do a double arrow. So if I write R1 and R2, that means we're going to switch those rows. If we multiply a row by a constant, say we multiplied row 1 by 4, all I do is just 4R1. So that's going to be implied multiplication between 4 and R1. And if we multiply a row by a constant, say we multiplied by -2 and then we added it to another row, we're going to write it like this. We're going to write -2 times R2. So this means we're going to take the second row, we're going to multiply it by -2, and we're going to add it to the first row. And what we're going to know is this last one that's indicated right here is the one that's going to change. So the last row in the operation is the row that's going to change. So in this example that we have right here, it wouldn't be R2 that changes, it's the last one. It would be R1 that changes. So in this example 3, what we're going to do is one single operation. It says carry out the row operation and write the new augmented matrix. So the only thing they want us to do here is just multiply row 1 by 1/3. So we're going to take row 1 right here, and we're going to multiply it by 1/3. That's it. So what that means is the other row stays exactly the same. So if I wanted to, I could at least go through and write this. So I can just write down the 2, the -5, and the -4 for the second row, because the second row isn't mentioned at all in this operation. And then we're going to multiply by 1/3. So 1/3 times 3 is 1. 1/3 times -9 is -3, and 1/3 times -9 is -3, and that's it. This right here would be the new augmented matrix. That's it. That's all you have to do on that particular one. Now on this one, this is not just a times a row like this one was. This is multiply a row and add it to another row. So here's what we're going to do. We're going to multiply row 2 by -2, and we're going to add it to row 1. So notice that row 1 is the one that's going to change. Row 2 is going to stay the same. So just like we had on this last one, I'm going to leave the 2, the -5, and the -4. I'm going to leave those. And then let's carry out this row operation here. So we're going to multiply row 2 by -2. So this is going to give me a -4. This is going to give me a +10, and this is going to give me a +8. Let me just double check that. So if I were to do -2 times each one of those, so negative times positive is negative, that would be a 4. Negative times negative is a positive. That's going to be a 10, and negative times negative, that's a positive, and that's going to be an 8. So we've got that. Now what we're going to do is we're going to take this result right here, what we get when we multiply R2 by -2, and we're going to add it to row 1, and we're going to replace row 1. So here's what we're going to write down. We're going to have a 1 minus a 4, so that's going to be a -3. We're going to have a -3 plus 10, so that's going to be a 7. And we've got a -3 plus an 8, so that's going to be a 5. So this would be the new augmented matrix. Okay? All right, let's look at one that's a little more what we're going to be doing. This is kind of a silly example right here. This one's not, because this is a very useful skill, but let's take a look at this one right here. If they tell you what the operation is, we're just going to carry this out. So you'll notice that this is take row 2, multiply it by 3, and then add it to row 1. So the row that's going to change is row 1. So row 2 is going to stay the same. So what we're going to write down is the 0, the 1, and the 2. We're going to write the line right here. We're going to take row 2 and we're going to multiply it by 3. So this is going to be this one multiplied by 3. So that's going to be a 0, a 3, and a 6. Now what I'd like you to notice is we're just using a copy of that. We've multiplied this row by a number, and we're using that to change the first one. So again, I'm going to highlight here. We're going to combine those numbers right here, and the one that gets changed, stays permanently changed in this case, is R1. So 1 plus 0 is 1, -3 plus 3 is 0, and -3 plus 6 is 3. So this right here is the answer. Now that seems kind of silly, like we're just playing a game with numbers, but I'm going to show you how this actually comes to our advantage when we're solving systems of equations. So on example 4, it says solve the system using an augmented matrix and row operations. So we're going to rewrite this as an augmented matrix. So I'm going to take the system of equations, and here's what the matrix does for us. It keeps track of the X column, the Y column, and the answer column, and where the equal sign is. And all we have to do is play a little game with the numbers. So I'm going to write down a 1, a -2, and a 2. Write the line right here, and a 3, and a -5, and a 9. So we need to solve this using row operations, which means we need to provide the brain power to figure this out. So here's how we're going to solve these, and we're going to avoid some frustration and get the correct answers. So the first thing is, please make sure you go slowly. Stop and think about what you're doing whenever you're doing it. Second thing, keep things neat and aligned. So notice how we've got the correct spacing here. Everything's nice and neat and aligned. Avoid fractions where you can. If you can avoid a fraction, please do. There are times where you can't avoid it. And then we're going to go column by column, and we're going to get the 1 in that column first. Then we're going to use the 1 to make the 0. And that will make sense here in just a second. And we want to get the goals in order when possible. So here's the goal. So the first goal is to get a 1 right here. So if we can do that first, that's what we want to do first. So we want to get a 1 right here. Then we want to use that 1 to make the zeros like we were saying here. So we want to do that second. So we've got that column taken care of. And then we want to take a look at the second column. We want to get that to be a 1. So this is our third goal. So there's the third goal, and here's the fourth goal. Okay, so we get this 1, use that 1 to make that a 0. Then we make this a 1, and then we use that 1 to make that a 0. Now, if you try and get those out of order, it makes it really difficult. And remember, you can stop when the matrix looks like this, and here's the reason why. If we come back up here and we take a look at this one that I did in such a silly way, let's say we wrote this as an augmented matrix right here. So I'm going to come down here. In fact, let me change colors so that this looks different. If I were to come down here and I wrote that as an augmented matrix, notice this would be 1, 0, and 8, and this would be 0 and 1 and 3, and we'd have a line right here. Well, this is the X column, this is the Y column, and then this is the answer column. So we can literally read off the answer right here. We can say, well, X, we've got 1X and it's equal to 8. We've got 1Y and it's equal to 3. So once you get it to that point, once you get the 1s down the diagonal and 0s everywhere else, you're finished and you can just read off the answer. So remember, each row represents an equation. So in this particular case, I'll do this again. Each row represents an equation. Okay. So this equation would be an X is equal to A, whatever that number is right there. And then this would mean there's no X's, there's only one Y, and it would equal B. So remember, these are both numbers, so you'd have X equals this number and Y equals that number right there. Now, this is called reduced row echelon form. So reduced row echelon form. A lot of weird names in linear algebra, like we're learning minors, cofactors, determinants, bunch of weird stuff going on, but here's what we're going to do. So we have the 1 right here. So we've got goal number 1 taken care of. Now what we're going to do is we're going to use that 1 to turn that into a 0. We want to take care of goal number 2. So in order to make that happen, we think, what do I need to add to 3 to turn it into a 0? What do I need to add to 3 to turn it into a 0? Well, I need to add a -3. So here's what we do. We're going to take row 1, because it's got a 1 in it. We're going to multiply it by -3, and we're going to add it to row 2. So this is the shorthand. This is the syntax that we're going to use here. This is how everybody's going to know the work that we're doing. So notice that row 2 is going to change. So row 1 stays exactly the same. So I'm going to go ahead and write down row 1 again. And then I'm going to change colors so I can show a little bit of work here. I'm going to multiply this row by -3. So if I multiply by -3, here's what I get. I get -3, I get 6, and I get -6. So I get -3, 6, and -6. Again, go slowly. Make sure you keep things neat and organized and stuff like that. So now we're going to replace row 2 with what we get when we add these together, when we add that multiple of row 1. So 3 minus 3 is 0. -5 plus 6 is 1. And 9 minus 6 is 3. So that right there is the second row there. Now we take a look at this and we keep the goals in mind. Goal number 1, done. Goal number 2, done. Now we turn our attention to goal number 3. We want to turn that into a 1. Well, sometimes we get lucky and goals will just kind of fall into place with us. So on this one, we've got that taken care of. Goal number 3 is accomplished. Now, once we've got a 1 in a column, we use it to turn the other ones in that column into a 0. So we need to turn that into a 0. So let's stop and think. What do I need to add to negative 2 to turn it into a 0? Say that again. What do I need to add to this negative 2 to turn it into a 0? Well, if I take negative 2 and I add 2, that would be 0. So we're going to use this 1 to make that 2. So we're going to take row 2 and we're going to multiply it by 2 and we're going to add it to row 1. Again, notice row 1 is the one that's changing, so that means that row 2 gets to stay exactly the same. So 0, 1, and 3, that part's taken care of. We're not going to mess with that. Now I'm going to change colors again. I'm going to do this one in green. We're going to take row 2 and we're going to multiply it by 2. So we're going to multiply this row by 2. So this is going to be 0, this is going to be 2, and this is going to be 6. So if I add those together, so 1 plus 0 is 1. This is negative 2 plus 2 is 0, and 2 plus 6 is 8. So this right here is the answer, and you'll notice again, x column, y column, answer column. That means x is equal to 8 and y is equal to 3. And if that looks familiar, it's because this problem right here is exactly the same as the one that we started with. So take a look at this right here, take a look at that equation, and then flip the page over and take a look at that first example that we did in such a silly way. Well, it turns out we can do all of this work by just keeping track of the numbers, the coefficients in the x column, the y column, and whatever those constants were in the answer column. Okay, now I'm going to slide down here. Okay, the point of this is not just to find another way to solve systems of equations. The point of this is to use our brains. So write down brains here. Okay, we want to develop our thinking power. We want to use our brains to figure out and follow a step-by-step procedure. So I realize this seems very weird. Why on earth would you learn a method that seems like it takes a whole lot more work than just solving it using elimination, using those standard techniques that we learned in Unit 2? Well, it turns out if you can figure out a procedure like this, if you can use your brain to figure out these types of procedures, then you can tell a computer or a calculator to carry out all of this tedious math. So if you look at this, there's nothing in here that was really difficult. We were literally just multiplying by negative 3 and then adding those numbers to some other numbers, multiplying by 2 and adding those numbers to some other number, and lo and behold, we go from this system of equations that's about the point where the lines cross, and we get this funky-looking augmented matrix that just says, oh, x is 8 and y is 3. So it's kind of cool that you can kind of remove the x's and y's from it, remove the whole idea that we're dealing with a system of equations, lines, x's and y's, and then just go through and deal with the numbers. So we're going to do one more example here, and then I'll turn you loose on the assignment. And I'm hoping that you see that if you do enough practice with this, it does get easier and actually turns into kind of a fun game here. So on example 5, again, it says solve using an augmented matrix and row operations. It does give us a little hint here. Check row number 2. There's a problem with row number 2 or equation number 2 here because it's not written in the correct order. We've got to have the x and y on the same side and then the number answer on the other side. So here's what we're going to do. We're going to move that over there. So this is going to be x. We would add 2y to both sides, and then we'd leave the negative 4 over there. So we're going to replace that one. Now we're going to write down the augmented matrix. So we're going to write down 3, 2, 4, x, oh sorry, not x, coefficient there, a 1, a 2, and a negative 4. Now let's double check. We've got a 3, 2, and a 4. We've got a 1, 2, and a negative 4. So we're all set to go there. Now there is something that we can do right away. Remember, the goal is to make this a 1, then use that 1 to make that a 0, then make this a 1 and use that 1 to make that a 0. So we've got 4 goals here. There's an easy way to do this one right here. If there's already a 1 down here, let's just do a row swap. So we're going to do row 1 swapped with row 2. So we'll go ahead and do that. And again, by writing this down, it makes it easy for somebody else trying to follow you, or you going back and trying to figure out where your mistake might have been, where you may have made that mistake. So we're going to write down 1, 2, negative 4. And then we're going to write down a 3, a 2, and a 4. And I'm going to confess a little habit that I have. A lot of times if I know I'm working with an augmented matrix, I don't write that vertical line. So I'm going to go ahead and come back here and write that vertical line. I do want you to notice that what we've done here by switching rows, that really doesn't change the system of equations at all. This is a line and that's a line. It wouldn't matter if they had given us this line first and that line second. That doesn't make any difference. So switching rows around certainly doesn't change anything. Well, we've got the first goal accomplished, so we're going to use this 1 to turn that into a 0. So again, the question is this. What do I add to 3 to turn it into a 0? Because I want to make that a 0 right there. Well, I'd have to add a -3. So we're going to do -3 times row 1, because that's where the 1 is. And then we're going to add that to row 2. So add that to row 2. So let's see what we get here. Now, again, we're changing row 2. So I'm going to come over here and I'm going to leave row 1 exactly like it is. There's nothing wrong with row 1. Whoops. Make that look a little bit better. So we're going to multiply by -3. So this is going to be -3. This is going to be -6. And this is going to be +12. Let's just double check that. -3 times 1, yep. -3 times 2, yep. And -3 times -4, yep, we're good there. So then we're going to add the two of these together. So that's going to be a 0. We like that. This one's going to be a -4. And this one's going to be a, let's see, what do we get there? We get a 16 there, okay? All right, so we've got that taken care of. We've got goal number 1 and we've got goal number 2. Now we're going to work on goal number 3. Well, in order to turn that into a 1, there are several different things that we could try, but you'll notice that if I take any combination of this one and I add it to the second row, this 1 is going to mess up that 0. So when we get to this point, sometimes we do have to work with fractions. So here's what we're going to do. We're going to take this second row and we're literally just going to take it and multiply it by something. So we're going to change that. Now, stop and think. What do I multiply -4 by to turn it into a 1? What do I multiply -4 by to turn it into a 1? Well, we'd have to multiply by, gosh, we want to turn it into a 1. We want to undo that -4. We want to multiply by the multiplicative inverse. So that's going to be -1/4. So we're going to do -1/4 times row 2. Now you'll notice that I have no row 1 mentioned in this command at all. So I'm just going to write down a 1, a 2, and -4. We're going to get that all set to go. And then we're going to multiply each one here by -1/4. So we're going to do -1/4 here. -1/4 times 0 is 0. So we'll put a 0 right here. Notice we haven't messed up goal number 2. Negative times a negative is positive, and 1/4 times 4 is 1. So there's goal number 3 accomplished. And luckily this works out nicely because we end up with -1/4 times 16, 16 over 1, cancel those. This is going to be a -4. So we've got a -4 over there, okay? All right, goal number 1 taken care of, goal number 2, goal number 3. Now we're on goal number 4. We need to turn that into a 0 and we'll have the answer. So for this one, here's what we're going to do. We think, what do I add to 2 to turn it into a 0? What do I add to 2 to turn it into a 0? Well, we'd have to add a -2. So we're going to multiply -2 by row 2, and we're going to add that to row 1. Again, notice that row 1 is mentioned last. That's the one that's going to change. So row 2 stays exactly the same. So 0, 1, and -4. And let's pause for just a second and talk about why we want row 2 to stay the same. Well, this is the X column, and this is the Y column, and this is the answer column. You can already see what Y equals here. Y would equal -4. In fact, if you wanted to step out of this and say, we already know Y equals -4, let's write down this equation and then plug it in, that would be fine. I find it easier to just go ahead and carry this out. So we're going to take this second row and we're going to multiply it by -2. So if we multiply by -2, we end up with 0, -2, and 8. Yep. And then we're going to go through and we're going to add that multiple to row 1. So this is going to be 0 plus 1. That's going to be a 1. Didn't mess that up. That's going to be a 0. And then we end up with a 4 right here. So again, X column, Y column, answer column, you can already see that Y was equal to -4. Now we can see that X is equal to 4. So X is equal to 4, so we write down the point where the lines cross. The lines cross at 4, -4. All right, done with that one. I know that took a while to get through. I appreciate your patience. We're going to spend some time practicing this, quite a bit of time practicing this. This is a really good mental workout. Works out your arithmetic skills and stuff like that. Please be careful as you go and fill out that self-assessment there. And please don't be afraid to kind of refer to this. You might want to read through that again before you get started. These can be frustrating and difficult to get the right answer if you're not careful. So please follow along with those, and good luck on the assignment.